everyone. So I'm going to show you something that we were not able to get to in chapter or in first semester. This is something you did in Algebra 1, but you will need your graphing calculator. This is not something that we can do in Desmos. So let me explain where I am. I am on page 53 in the white packet. This is a video for that particular homework problem, and this is what you will be submitting into OneNote. And you will be getting a sheet in class, or you should have the sheet that gives these calculator directions. But obviously, you need to see this live in action as well. So I have my graphing calculator. It doesn't matter if you have an 83 or an 84. The direction, it might look a little different as you go through. So I'll be doing this on both calculators and then showing you the different screens. So what we're doing is we have some data here. This is a census population of Denver since 1950. And these are the years since 1950. So if you notice when you see 0, that means this is the year 1950. And then this would be like 1960, 1970. So I'm just going to quickly fill in those years, and you can do the same. And then this is the population in thousands. So this is 415.8 thousand. So if you actually want to see what this is in thousands, you would just take this number times 1,000 on your calculator, and you would see that this number is actually just worth 415,800. Okay? So essentially, when you multiply by 1,000, what you can do is just move the decimal 3 times to the right. So like in this one, if I move it 3 times to the right, this just becomes 492,400. So, but, you know, we don't want to type those big numbers in, so that's why they have written it in this like smaller condensed format. So what we're going to do with our graphing calculators is we're going to make a scatter plot of the data, and then we're going to run a cubic regression. And regression means that we're just going to find a cubic shape, this kind of curving line that best fits the points. It's not going to fit it perfectly, but it's going to do its best job. And once we get there, we will be writing down the equation, and then we're going to start to use that equation to answer these questions down below. So the way you do this, regardless of your calculator, is the first thing we're going to do is I need for you to go to your y equals button, and I want you to clear out any equations that you might have in there. And then the next thing I want you to do is go up to where it says plot 1, plot 2, plot 3. Go up to plot 1 so it's highlighted, so it's flashing highlighted, and hit enter so it stays highlighted. Okay, so that's our first goal, is to get that done. So now what we're going to do is we're going to get this data entered into our calculator. And to do that, what I'll be doing is I will be pushing the stat button. So I press the stat button, and according to your paper that you will have in front of you, it says, you know, just stay on edit, which we're going to. And if you notice, I already have this data entered into my calculator. So you should see at the top L1, L2, L3, L4, L5. If for some reason you are not seeing this, hopefully I remembered to make sure that these were in your calculators, but otherwise I could just watch along because it's kind of tough to explain. Okay, so let me show you how you type this in. You need, again, we're going to be working with L1 and L2, and if you have stuff in there, which is very possible, what you want to do is use these arrows over here, and you want to arrow up to L1, and you want to hit clear, enter. Don't hit delete, hit clear and enter. And then the same thing, I'd go over to L1, L2, and I'd go up to L2 so it's highlighted, and I would hit clear, and then I would hit enter. And what we're going to do is we're going to make our years be our L1. Oops, and we're going to make this population be L2. And the key is you just need to go slowly and type. And what we're going to do is what we're going to type in is what they have. We're not going to put in 1950. We're going to type in 0, 10, and we're just going to go in order like they did. You don't have to go in numerical order, but theirs is, so we will. So just 0, I hit enter, and it takes me down to the next one, and I'll type in 10, 20, 30, 40, 50. And before I'm done, I just want to make sure that all my data is correct, because it's very hard to catch mistakes if your data is incorrect. And then I'm just going to arrow over to L2, and I'm going to type these numbers in. So the only thing I need to do is just make sure that 0 and 415.8 are paired together. Okay, so typing them in, hit enter, then I can put in the next number, enter, 514.7, hit enter, keep going through them all. And when you're done, just double check that they are correct. This is where probably the mistake would happen if you were typing things in. So I just want to double check that each number is what it's supposed to be. Okay? So now what we're going to do is that we've got our data in there. We're going to see what this looks like when it's graphed. So what I want you to do is I want you to press zoom. And if you look at the bottom, number 9, it says zoom stat. So it's going to zoom the data so we see all the points. So I press zoom 9. Now, if it's not looking the way it is, you need to rewind this video because you missed a step then. So if you notice, we want to run a cubic regression because if I do connect these points, that's going to be that kind of curvy line, and that's a cubic. All right? Now, it could be a 5th degree or a 7th degree, but we're going to tell you to run a cubic regression. So what we're going to do is we're going to force the calculator to come up with this crazy equation that when we graph it, will meet as many of these points as possible. So now what we do is we go back and we press the stat button, and this time we're going to arrow over to calc, and I want you to choose option number 5. So you can, 6. You can either press 6 or scroll down to 6. It doesn't matter. Okay? And this is where you're going to see some different options based on your calculator that you have. All right, so I've got the 2 different operating systems on my calculator. One is definitely a little bit harder to see. I don't know how to make that better, but oh well, you can kind of see overall maybe if I angle it. Okay, so what we want to do is we want to choose option number 6. So again, on both calculators, I'm just going to press 6. So hold on, stat. Okay. All right, so this is where you're going to start to see the differences on there. So this is the older operating system, and this is the newer operating system. Let's see if we can, there we go. And in the older operating system, when you see this, you actually just have to hit enter. In the newer operating system, what you want to do is just scroll down to calculate. Now it should say L1 and L2. So I'm just going to arrow down to calculate, and I'm going to hit enter. And then you're going to notice that we're going to have the same numbers popping up for A, B, and C, and D. A, B, and C, and D. Now this has something else. We're not going to worry about this R squared thing. What we're going to do is we're going to take these numbers 3 decimals back and put them in for A, and B, and C, and D. So, and that's the equation that I'm about to write down on the equation right here. So we can call it any function we want. Let's say we call it f of x. And I'm just going to write this down. So 0.009x to the 3rd power plus, then they have a negative. Make sure these decimals pop up. Here comes just x. And then the number that has no x, like that. So again, what I've done is I've just taken A's value, put it with x cubed. I've taken B's value, 3 decimals back, so I did follow the rounding rule. X squared, I take C's, put it with x, and D just goes at the end. Okay? So now what we're going to do is we're going to enter the equation into the y equals of our calculator, and we're going to use this to approximate the population in 1995. So now on any calculator, what you'll want to do is, actually let's do this. Let's go ahead and type it in first. So point. And again, at this point, it does not matter your operating system. Just a careful note, that negative, make sure it's the negative sign and not a subtraction sign, or you could do minus this amount. That is your other option. And again, you just want to make sure you type it in the correct way. And then what I want you to do first is just hit graph so you can see the shape that it's going to form. And for some reason, I must have typed something incorrectly. So I'm going to pause this real quick and just double check to see where I messed up. Okay, so I figured out my mistake. So what I want you to see is this now create an equation that tries to follow all the points as best as it can. So what I want to do now is I actually don't need those little dots to show up anymore. So go back to your y equals button and go back up to your plot 1, so it's flashing on there, and hit enter. And now when you hit graph, it's actually just going to show the shape and leave out the points, which is our goal. We only want to focus on the shape now because it's this equation, this shape, that's going to help us answer all the other questions. So according to your model, in what years was the population 5,000. So remember, all of the x values here, that's your years, and the population is your y. So since the population is 5,000, I'll be putting 5,000 in for y, or in for f of x. So the way I would do this is, if I was writing this, which I really don't want to write this all over again, I'll just write some of it, is this side is y1, and I'm going to go back to my graphing calculator, and I'm going to put y2 in there for 500. So I'm just going to press y equals, hold on a second, we got some rowdy dogs here, and I'm going to go to y2 and just put 500, because remember that 500 is 500,000. And then I'm going to graph it, and hopefully you can see that line coming across. So I want to see in what years, so there's multiple years in which it was 500. And this is where we go to second trace, and we choose, second trace, and we choose that intersect option, option number 5. And you just want to move your cursor to the one that you want to look at. So there's 3 of them, I'll look at this one. So I'll just hit enter once I get there 3 times. And this is the year, or how many years since 1950, and this is the population. So I'm going to write that number down. So we've got 45.102. Let's do one more together. So I'll hit intersect, and again I'll just move my cursor over to a different one. And once I get to where I think it is, I hit enter 3 times. So again, this is how many years since 1950 to have this population. And then I will let you do the other one. But I want to know in what year. So these aren't years. This is the years since 1950. So if I add 45 to 1950, then at that point, this is the year 1995. So somewhere in 1995. And then we'll just keep this at 23. We're not going to round it up because it's somewhere 23 years after. So that would be 1973. And then you'll have one more amount that I'll ask you to do. Okay? And now, according to your model, what was the relative minimum population? Since this is already in my calculator, I want to go here. And again, I always go to second trace. I'm going to choose minimum. And this is where I always start with where I think it is. So I move the cursor to where I think it is. But then when it says left bound, I go to the left a few times, hit enter. And then for right bound, I go back to where I think it is. And then I go to right a few times, hit enter. And in this many years after 1950, this is the population that it's going to be. So, let's write this down. So 36.412, that was my x value. The y value was this amount. Can always go 3 decimal places. I am rounding. So this is years. So about 36 years after 1956, so that's in 1986. And if I just take this multiplied by 1,000, which again is moving that decimal 3 times to the right, my population is, it basically becomes a comma instead of a decimal. Now we're going to find the average rate of change between 1970 and 1990. We are not using this data. We're using the data from here. So this is where I want to go to my table. Well, you could go to the table, or I'll show you another way. So I want to look 20 years and 40 years. And here, so I'm not scrolling all over the table, if you actually go to second trace and choose value, type in 20 for 1970, and I get its y value. So 508.996, and then I'll do 40, same thing, do second trace, choose value, I'll put 40 in, I'll get its y value, and at this point I'm going to let you finish the average rate of change, which remember is just a fraction with you subtracting your y's in the numerator and your x's in the denominator, and finish it so that you get a denominator of 1. All right, last question. So if the population of the Denver continues to grow according to this model, when, so we're looking for x, will the population reach 1 million? So that means, again, we want to make f of x be 1 million. And 1 million, if you just take 1 million and divide it by 100, or divide it by 1,000, or move that decimal 3 times to the left, you're going to see that the y value that we'll be using is 1,000. And that's just simply, I'm going to go back to my graphing calculator. I'm going to go to my y equals. I don't want to look at 500 now. I want to look at 1,000. And again, that is 1,000,000 in this data. So right now when I hit graph, you're going to see it's not going to fit on there. You're not going to see a horizontal line coming across like we did before because our window isn't set up for that. So if you just press window, our Y max is only going up to 579. So what I want to do is go to Y max and change it to be above 1,000. So maybe like 1,200. And then when you hit graph, you're going to see that line hit. Maybe, we'll see. And if you notice, it's still not quite working because it's now meeting more to the right. So I have to go back to the window and adjust going further right, which is X max. And maybe just make it like, I don't know, make it 200. To make it 100, that might work too. Yes, it probably would have. All right, here comes the other line, and then I'll let you find this point of intersection. So you will hit second trace and find where they meet. And then that is your problem number E, and then you'll submit this page to OneNote.